Hello, hello. Tout, 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 tout. Et aïe, aïe, aïe. Yalla, yalla. Coucou, Larissa. Remove. Yeah. Um, so, wow. Okay. Let's wait a bit. So, Voila, gonna come like in 2 or 3 minutes, something like this. She's a bit late. But no worries. Uh, Hope you're doing well as usual. I will put a reminder. Um, to, 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 to. Uh, I put like Google Meet, and so I just remove it. Probably some people were there. No worries. All right. Tac, tac, tac. Question one. Tac. Motion. Tac, tac, tac. Mm. Tac. We coming. I put the link on the chat for everyone to join. Mm. Oh, pop, 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 pop. Okay. Pin, notify. Up. All good. Oh, 10 people just joined. Nice. All right.
Hello.
Hey, voila.
Hi, Sanin. How's everyone? Welcome, welcome.
We're doing great, apparently.
Apparently. No, I can see it. Everyone's doing great for sure.
Yeah. So we're gonna wait 1 or 2 minutes because I just put a reminder with the link. But all good. Um, oh, probably before I can just present the courses for this week. Yes, I will do that. Makes sense. All right. Ooh la la. I'm lost. Um, tac. Okay, so you can see that right now. So during this week, we're gonna deep dive the basic concepts about Solidity. Solidity is the main, like it's the programming language that we are using on the Ethereum ecosystem to write smart contracts. So um, just it's like we will deep dive using a specific resources that is called Cypher Updraft. So in fact, um, into these courses, the goal of the goal of the bootcamp is to provide additional context about these courses, and it's something that you can get as a self assignment on your side. It's like 5 hours of content itself, but with some quick video that you can show with different session section. So take your time learning through it. And the goal of the base camp, the boot camp, is to provide, yes, more like specific, if you have a specific question about it, etc., and also going through the different concepts itself that are into these courses. I wanted also to talk about something else. So I don't know if Sneha is here. Let's. Uh, oh, you can't hear me. Sneha is not here. Um, but actually, Sneha has done something cool. So after this base camp, this boot camp, what you can do is also going through 30 day building with Solidity. So it's some little challenges that you can do from fundamentals to more advanced one for writing smart contracts. It's really beginner friendly, and I know I put everything here. Yeah. So during the next 2 weeks, you're gonna do this thing and this thing. All right. All good. Great. And so you can see all the video related to each challenges about 30 days building with Solidity. It's really, really useful. I know a couple of people already done it and learn a lot through it, because you can also push your smart contract on GitHub and having like a better public building on your side. All right, all good. Um, so today we're gonna deep dive into this specific topics, and when the session is over, so we update the notion as we have done for the base camp, the discovery base camp last month. All right. And if you have any question, you can put it on the Telegram. We have like a dedicated chat for that called Solidity. I think we are good now to start.
Yay. Thank you for the introduction.
You're welcome.
All right. So, just like Celine said about the Solidity smart contract development, you can check out all of the courses here on Cypher and Updraft. Um, 1 minute. Yeah. Yeah, you can check all of the courses here on Cypher and Updraft. And today we're doing the Solidity smart contract development. Wait, why is it so big? Oh,
Indeed, it's so big.
right?
Yeah.
Yeah. I think it's my settings. But yeah, so we're doing this, which is the first section, simple storage. We're doing from the lesson 1 all the way to lesson 8. So with every section, you will get a quiz. Try to do that like on your own time. Yeah, you can get multiple quizzes in one section. So that's really cool. I love Siphon Updraft. It has really good courses and it's really fun. And the community is cool too. So welcome to Solidity 101. Yay. Let's do this. All right. So who am I? I'm Khawla. I'm based in the UAE, or what people know, Dubai, I guess. That's the only city that people know. And then I'm a technical product manager at Dia Data. We do cross-chain oracles. And I got into crypto back in 2020, or like end of 2020, like 2021, and then worked a little bit as a blockchain developer for around 2 years. And then I transitioned into product mid 2023. So it's been 2 years in product, and that's fun. And then also, I think last year, not last year, I think this is an old slide. That was back in, yeah, actually, yeah, 2024, we launched Solidity Sisters. So that was fun. And we were all just like learning together Solidity. But unfortunately, it's not as active now.
You are doing the inverse, the contrary of all developer journey. Like we are
Yeah,
starting as a developer and then after that transitioning as a product. And I know some people inside the ecosystem doing the contrary.
really?
Yeah.
Wow, I didn't know. Okay, that makes me unique. I like that. I want to be special. All right. So today we're going to learn about Solidity. So I'm curious how many of you have, I don't know, like dabbled with Solidity, or I want to know like what are your general observations of the language? What kind of, is it object oriented, for example, or like what did you notice about Solidity and the way it's written generally? Were there any special observations that you have?
Actually, they are all new about Solidity.
Really?
Yeah.
Wow. Okay. And so like they're all familiar with like Web2 languages, I guess, like
Yeah.
something like JavaScript. Okay, cool. So then one of Solidity features is that it's object oriented. So I'm sure if you've worked with Java, you know what object oriented is. So it's like having, it's like saying, it's like a way of defining a class and then saying this class is a, or for example, yeah, actually I have this tab open. So for example, you have a button, you can define a button as a class, and then within that class, this button has a label. It has X size, Y size, and certain positions on the coordinates, on the X and Y coordinates. And then it also has methods. So it's sort of similar. Solidity is an object-oriented language, and it's also high level. So that means that it like the language is written in a way that anyone can understand. Like it's a human readable language. And it's not low level, like assembly, for example. If you're familiar with assembly, it's a low level language. And it uses a lot of curly brackets, just like JavaScript, for structuring data. And then it's also statically typed. So that means that anytime you declare a variable, you have to specify what is the data type of that variable. And I think that's not the case for JavaScript, right? Yeah, I think so. And then it supports inheritance, creating libraries, and complex user-defined types, and it has a bunch of other features. So let's get into the data types. We will look into the data types and then we'll try to guess together what would be the default type for, the default value for each data type. So we start with Boolean. I think we're all familiar with these data types. These are the same data types that you will find in other programming languages. There's Boolean that could be true or false. There is unsigned integers, which are positive integer values. It can be 0 or it can be anything from 0, like positive integers essentially. And then int would also store negative integers. And address is just an address. If you've seen an Ethereum address before, if you use MetaMask, um, for example, this one. Wait, for example, an address like this, it would look something like this. Um, that is an address and it can store these kind of values. And then you can also access method on addresses like balance and transfer. And then there's also bytes and strings. A string is just a string. It's like any human readable string or set of characters, but bytes are more like strings that can, for example, hexadecimal values, they can contain hexadecimal values. Um, those are the types of values that this data type can store. Yes. So now let's do this exercise together. And what do you think each type's default value is? I like to do this exercise with everyone. So for example, what would you think is the default value for Boolean? So if I go here and I don't know, maybe we can use the storage contract.
Oh,
Wait, sorry.
could you present Remix?
No, not yet. Oh, actually, good idea. Let's present Remix. So Remix is like an IDE, but it's like a browser IDE that you can use, something like VS Code, but then you can use it just on your browser to compile contracts, write contracts, also deploy contracts to a blockchain. So that makes development really easy and fast and quick. But usually, like when you want to develop like production level contracts or set up a big project, then Remix is not the ideal environment for doing that. You need to use frameworks like Hardhat or Foundry to develop these smart contracts because they also come with a bunch of other tools. And you can run a bunch of other things with them. But like with Remix, it's kind of limited. It's more of like a light development environment that you can use and access quickly.
Yeah,
So if
it's well used during hackathon.
yeah, like it's very accessible and easy. And if you look here, if you should first go to remix.ethereum.org. I'll drop the link here. Oh, you already did. Thank you. Can you do basic front end edit? No, I don't think so. But you can run scripts. You can run JavaScripts, yeah, JavaScript scripts or scripts in general. And you can also run tests here. You can write tests. But I think a whole front end on Remix, no. I have not seen that before. Yes, so here you can see these are the projects. These are like folders that have scripts. Let's say, let's start with the contracts. So these are the contracts. And in Solidity smart contracts, they end with .sol. So that's how you know that this contract is written in Solidity. And then if you say, let's say you developed a contract and now you want this contract to be available to everyone, you have to deploy it to a blockchain. And so to do that, you will write a script that will help you deploy it using your, let's say, wallet. You will fund your wallet with some tokens. And then you will, if you have a constructor inside your contract, you will pass the values that are needed to deploy your contract. And then you'll write a script that can do all of that for you. And you, of course, you need to set up an RPC, and you need to set up a bunch of other things so that it can deploy it to the destination chain. So you can write scripts here, and then you can also test your contract. You can either write the test cases in Solidity, like the one here, or you can write the test cases in JavaScript. Yeah. So that's how it looks like. This is the layout. And then this is a search. You can also search through your files, your projects. This is the Solidity compiler. So once you write your contracts here, you need to compile it. And then that bytecode, I think it produces a bytecode, right? And then that bytecode is what is used to basically understand how to interact with the contract. But let's not get into the compiler part. And then here you have the environment, which if you want, like Remix gives you this virtual environment, so like a playground that you can test with. But let's say you don't want to deploy your contract in Remix, you want to deploy it on, let's say, Base, then you can connect your wallet and through Wallet Connect, for example, and then it will use your wallet connection to deploy it to Base instead of using this virtual environment. This is a debugger, but here inside the deploy and run transactions tab is where we can see all of our deployed contracts, which we will do that in a bit. But that's just a brief overview of Remix and how it works. Yeah, Remix is super helpful for testing things really quickly. All right.
Do you have any question about Remix? Um, because I mentioned that four courses related to Cypher are using Remix, and you're gonna interact a lot with this tool, just to deploy quickly a smart contract and so on.
Yeah.
Just to be familiar with it l- soon. Looks okay.
Okay. Sounds good. Um, wait. Like I'm trying to see if there's a simple diagram that I can use. Yeah, something like this, just to show you. Just to show you what happens, like when you compile. When you compile your contract, it produces a bytecode and it produces an ABI. And then I think the bytecode is what gets deployed to the EVM. But let's say you want to create a front end that will interact with the contract, then you need this ABI to access the methods that are on your smart contract. But we'll get into this later. Like you shouldn't concern yourself with that for now. Let me see if there are any questions so far. No questions. I think ABI stands for application. Wait, I'm trying to look things up with you guys. Mhm. Okay, application binary interface. Yes, thank you. All right.
Using every time some acronym.
Yeah, so many acronyms.
Yeah,
True. Okay.
but
So what do I want to do here? Yes. Okay. Let's try defining random variables and then seeing what their default values are. So let's start with the first data type, which is Boolean. Let's say bool um, is true, for example, or maybe like let's say boulevard. And then we compile this, let's say, and it should show up here and we deploy it. Wait a minute. Let's do public. Let's do function. Maybe that's not typed function. When that get compiled. Okay, there we go. So what would you say is the default value for this Boolean variable? Would it be true or false? False. False. Okay, let's see. True, it's false. Yay.
yeah, it's like on the like it's mentioned, like if you can show where it's mentioned that it's false on the,
Where? Ah, here.
yeah.
Yes, thank you. It's here. It says false. So so as you can see, I don't know if you've noticed, but when I wrote bool and then I declared the variable without saying that it's public or private or whatever, then I couldn't see that here. I couldn't see this button. So if it's in blue, it means that it's a getter function. So every public variable that you declare in Solidity gets a default getter. I'm not sure if you're familiar with the concept of getters and setters, but yeah, it gets a getter, and then that's how I get to call it. So it's essentially a function that can retrieve the value of this. Okay, let's try another one. Let's try an unsigned integer, which means that it can carry positive values only. And let's say uint public number. Delete, compile, deploy. What would you say is the default value here? Yay, okay. Everyone else agrees? It's 0? Okay. Yeah, it is 0. Nice.
It's a game today.
Yeah. Let's try one last thing. Maybe let's try let's try a string and let's try an address. Let's try an address, public, my wallet. And let's try a string. What's a string? Public, my name, I guess. And let's compile this and run it. Okay, what is the default value for my wallet and for not for my name? My name and my wallet. Yeah, 0x blah blah blah. An empty string, correct answer. So for my wallet, it would be the 0 string. Sorry, the 0 address. And my name would be an empty string. Correct. Okay, cool. So now I think we're a little familiar with the data types in Solidity. Maybe I would say like the tricky thing would be like uint versus int and things like that. And also address is a new concept that doesn't exist in other programming languages, I think. Yes. So I used to do this exercise for like we used to do a bit of math here, but it's okay, maybe I'll keep it for later. Not today. Remember? It was too intense, yeah. So let's get straight into functions. Functions, similar concept that you find in other programming languages. You have, wait, let me make sure my code is ready. Actually, oh, I just realized that we never spoke about how to write a contract. Sorry. Maybe we can start from there. Okay, so now let's create a new contract that is called simple storage. And you should always make sure that the name of your file matches the name that you give to the contract. So when you say, just like when you say class person, you start with this keyword contract, and then you give the name of the contract. Always make sure that this name matches the name of the file. I think that's a good practice, but I don't think it would do anything in terms of compilation, if I'm not mistaken. And in Solidity, we start with specifying the license. So you start with, wait, let me see where's the reference for it. Yes, so license identifier. Let's see. Okay. So you should always start with this license identifier. Like it can have multiple values. Like you can say MIT, you can use GPL, you can make it unlicensed. And okay, thank you for sharing. Yeah, so essentially you start with specifying the license for your contract. And then you start with this keyword, also pragma keyword, which is essentially defining the version of the Solidity compiler to use. So let's say we're going to use version, let's see.
Probably it's something that you remember right now during the Discovery Base Camp. So Kevin explained this parts.
Really? Perfect.
Yeah, I think so. I remember. But it's always great to have a reminder.
Yeah. Yeah, exactly. So let's read this together. The pragma keyword is used to enable certain compiler features or checks. A pragma directive is always local to a source file, so you add pragma to all your files if you want to enable it in your whole project. And then you need to specify the compiler version here. And then what else? Yeah, let's not get in too much into this. But let's say we'll use version 0.8.13. And then when you use a hat, you're saying that this contract is compatible with starting from version 0.8.13 and above. So you can use any compiler version starting from 0.8.13 to compile your contract and above. And so the way that you can find the new compiler versions that are being released are through either the documentation or through the repo here, Solidity. As we can see, the latest version of the Solidity compiler, right now we're at 0.8.30. And it's always a good practice to use the latest like stable version of the compiler. And yeah, they regularly like release what are the new features, what have they fixed. So keep an eye on this too. This is good. And yeah, so we start with the license identifier and then specifying the Solidity version, compiler version. And then you start with the keyword contract, and then you give a name to your contract. And in this case, we'll call it simple storage. And then just like a class, it will contain a set of variables and it will contain a set of methods. And everything, like the entire logic, should be within those curly brackets, within the contract object. So in this simple storage contract, we'll just have a method that will take your favorite number and store it. That's all. Like that's all it does. So if I want to store my public number somewhere, I will need a variable that can hold integer values, right? So I'll use uint and I'll make it public and I'll call it favorite number. And then we'll declare a function, and the function is written in a similar way to other programming languages. So you start with, no, actually you don't need the return type. That was misleading. You'll start with the function keyword and then the function name. Let's call it store. And then you will put the parameters if your function is accepting parameters, and if you need certain parameters to be passed. So yeah, for your implementation, for your function implementation, then you will specify them here within those parentheses. So let's say we will need the user to pass their favorite number, which is also a uint. And it will be public. And what it does is that it will assign the number that you pass. Let's call it favnum, just to like distinguish it, to this global variable that you have, or this variable that exists within your contract. So you'll say favorite number is equal to favnum. And now we get into the visibility part. So you can specify how you want, like you can specify the visibility of your function. Let's look into this cheat sheet. This is also really helpful. if you go down here, you'll see the function modifiers. So it's like keywords that you add to your function to say how you want this function to be accessed. So if you say something like, this function is public, what does that mean? You can go here and you can see. It says visible externally and internally. Creates a getter function for storage slash state variables. So that means that this function is visible to other contracts. Let's say you define another contract here. Then that function will be visible to the other contract internally. And also externally, other people can use it and interact with this function. So these are modifiers and keywords that you can give to your function to sort of control how people can access your function. If, let's say, you don't want this function to be accessible, let's say it's a super, super sensitive function, you don't want it to be accessible by other contracts, then you can mark it as private. But of course, there are other restrictions that you can do in the future. Let's say, yes, it's private, or maybe let's say it's, for example, let's say it's external. It's an external function. Yes, other people can use it outside of like any user can come and use that contract. Sorry, that function. But you don't want any user, let's say you want to control the access, then there are like other layers to it. You can say only this certain person with this address can call this function, even though it's external. You can see it, I can see it, everyone can see it. I mean, but you cannot call it, like you cannot make it execute its implementation because it has, let's say, a modifier that's called only owner, and only a certain person with that specific address can access it. So there are like different ways that you can control the behavior of your function, especially when they're like super sensitive. And also, yeah, sorry.
Just highlighting that it's an important point notion to master for writing.
Yeah, exactly. So let me access controls. Mm, yeah, you can check a library that is called Open Zeppelin. And in Open Zeppelin, you'll see this tab for access control. And for example, this function, the contract, let's say is ownable. And let's say you have, wait, actually, yeah, where's the modifier only owner? Okay, let's not confuse you, but I'll just share this with you so that you can learn more about access control, for example. So yes, so there are a bunch of things, but it's not just for controlling the access. It can also be gas efficient. So if you mark it, I think if you mark a function as external, it will be more gas efficient. Like it will not cost as much to execute this function versus marking it as public. So there are also like some stuff that has to do with gas efficiency, and also another side to it is the access control. And yeah, and that's what it takes to be a Solidity developer. Like you need to be aware of all of those things. Yes, it can be overwhelming, but it is important because you're not just writing a piece of code. You're making sure that it's gas efficient. You're making sure that it's secure. You're making sure that, because once it's deployed, you cannot reverse, right?
And you can use to some templates because yeah, it's can be a lot to write.
Yeah,
Like
exactly.
so don't hesitate to use templates. I sent a link regarding that using Solidity by example.
Yeah, that's true. And then what were we saying? Yes. Okay, so this is a simple function that will store your favorite number to this public variable, right? And then what else do we need to do? Let's see how this works. Let's compile it and deploy it. And here, as you can see, if it's marked as, I think like there are color codes in Remix. If I remember correctly, if it's orange, that means I think that means it's public, right? It means it's a setter function that is public. Um, but yeah, I kind of forgot the color codes, to be honest. So let's store a number. Let's say my favorite number is 3. This will cost gas to call. So you kind of have to pay for this in order to call it. And you can check here the gas, the transaction cost. It took for what? For 43,718 gas. And then now what it did is that it stored just for storing my favorite number into this variable. And now let's call this the getter function for this function, for this variable to see if 3 has been stored or not. And yes, it did. So now it holds a value of 3.
Je did ask a question about contract modification, how to modify the state.
Where's the question?
I think it's
Once contract is deployed. Yeah, you can also use upgradable contracts. So you can also look this up. But some contracts are upgradable, and then you can somehow upgrade the contract implementation. Upgradable contracts. See if there's a result. Yeah. There's also an open Zeppelin guide. Here, I'll leave a link. Yeah. What were we saying? Okay, let's go back to this. Okay, now we want to explore other concepts. So something like arrays and structs. What an array, if you're familiar with it, similar concept to other programming languages. You have like if you declare an array of size 5, let's say, you have all of these elements within the array, and each like the way that you can access it is by saying num0, num1, num2. These are like, and like each slot gets an index and it starts from 0, and that's how you can access it. So essentially, an array can hold multiple things. And it could be like a fixed size or it could be dynamic. Similar concept also exists in Solidity. So you can either say this array or this bucket holds 5 elements, or you can just declare a bucket and it can hold whatever number of elements that you want. But of course, they all have to be of the same type. Do we have other questions? Okay. Someone's resharing the link. Okay. Just quickly, where should I start? Okay, maybe let's say we want to store, instead of a single favorite number, we want to store an array of favorite numbers. So we will say uint, but this time with brackets, and then we'll say public favorite numbers. And now instead of holding one value, it can hold multiple values. So we'll change this logic now. If I want to, let's say I have an array of favorite number 3, 4, 5, 6, then this one, so if I want to access this one, I'll have to say favorite numbers and then pass the index of the first element, which is 0. If I want to access 6, then that would be 0, 1, 2, 3. I'll say favorite number and then I'll pass 3. So it's a similar concept to all of the programming languages that you know. Nothing new here, actually. Um, and then if I want to push an element or a value into this array, I will have to use the push keyword. I think some other programming language also has this push keyword, but I don't remember. We'll use the array name and then we'll say dot push favorite number, like that. So let's see how this works now. We'll recompile. What happens if we find that there's a bug in our contract after deploying it? You have to redeploy. Unless it's I'm actually did not venture into the world of upgradable contracts. I haven't written one before. But there should be a way for you to sort of like point to a newer contract, I guess. Like I'm not sure, maybe I don't remember the concept, but maybe there's like a contract that points to another contract, and then in case you want to upgrade that one, this one will not be impacted, and then it will just point to the new contract somehow. I'm not sure. I don't remember honestly, but we can look into this together. Um, you're welcome. And yes, so now let's try this. And then we'll get into the structs concept. And also structs, similar thing. Like if you probably written in another programming language, you'll just find this like repetitive, nothing new. Yes, so simple storage, we will pass a favorite number here. As you can see, if you want to call this array, then you have to pass an index here. And store, I will store 3. That's one transaction. And I will also store 4 and 5. Let's say 3 values. So now let's say I want to access the first value that I entered. I will say I will pass 0 as the index, and then I'll call the array. As you can see, this is the output, which is 3. If I want to access a second value, I'll pass 1. It will return 4. If I want to access the third value, it will have an index of 2. And this is the output, which is 5. Let's say if I want to access the fourth value, even though I don't have a fourth value stored, I'll give it an index of 3. It's always like your number minus 1. It will revert, right? It will throw an error because this number does not exist. It doesn't have 4 slots. It only has 3 slots. So similar concepts to regular arrays. And then let's get into structs. Structs is a way of like, let's say that an integer does not, like you're trying to declare a new type and your new type does not fit into an integer. It's not an integer, and it's not a Boolean value. It's not an address. It's a bunch of things. Then you could use a struct to define a new data type. So let's say you want to create a struct of a person, and this new data type is a person, and that person can have a favorite number and it can have a name. Then you will use the keyword struct and then give it a name. And yes, it is intentional to have the name in uppercase, like the first letter. And then you will declare 2 types within, or 2 data types within, or 2 variables, 2 properties within the struct, which are favorite number and name. And and that will be your new data type. So you can have a variable, like a variable of, I don't know, maybe let's say of type person. You can say person. 1 minute. You can say person is the data type, it's public, and the variable is called person. So that's how you use, or that's how you introduce new data types within your contract. Yes, so now we want to create a bunch of these people. Like we want to store, like we want to store now a person. So the store function now will work as you'll pass the favorite number and you'll pass the name, and it will store it into an array of persons. So you'll say person. Now it's an array of person because just like you can say uint array, it can also be person array because it is treated as a data type. And then you can declare it as public list of people. And now you can pass the favorite number of the person and add another property, call it, sorry, another parameter and call it a name. And now you can say, what can you say? And now this is how you this is how you push or how you initialize a person variable and then push that into the array of persons. So you'll say let's say person. 1 minute. Let's say list of people dot. Again, it's because it's an array, you can use the push method. And this time to initialize a variable of type person, you'll say person, and then you'll do parentheses, and then you'll create sort of like an object, and that will be passed to person. And then you can use those two properties that you've already declared, and then give it the fav num as the value. And it's like you're saying this this value that you're passing here, assign it to this property, and then this value that I'm passing here, assign it to this property, and that's how you do it here. But this might be a little confusing, like if you want to distinguish the parameters from the what do you call it? From the properties declared here, then you can just do an underscore like that, just to make it, just to not confuse these two. Let's see, why is it throwing an error? It must be memory. Yeah. We'll talk about that in the next session. And then let's see how this works now. I see there are questions. Is struct like constructor in Java? No, it's not. Yeah. Yeah, more like objects in JavaScript. I think structs also exists in Java, no? Structs in Java.
Yes, I think I say in Java, not JavaScript, because there is a constructor, not in Java, in Spring Boot.
Yeah, there is a constructor in Java, true. But also struct somewhere.
No?
Maybe in JavaScript. But it's not the similar concept. We also have a constructor in Solidity.
Okay.
Yeah, it is called constructor also like that. Same thing. But struct is more like a data type. It doesn't do any implementation, just stores values.
Okay, thank you.
Welcome. And now let's try let's try calling the store function. The store function now, as you can see, It takes two parameters. It takes your favorite number, let's say 4, and it takes a name. And you have to put it in, what do you call it? Double quotes. And then say, I don't know, let's try my name, Khawla. Transact. As you can see, every time you interact with a function in Solidity, you have to pay gas. And sometimes it's also not just gas. Some people also charge you for calling those functions. For example, we have in our smart contracts a function for requesting data. Like, so if you want data from an oracle, what an oracle, like, it brings data from the outside world, let's say from the stock market, and then brings it to your contract. If you want to call this function, then you have to pay us some fees that is charged on top of the gas fees. So as you can see, every call requires gas, but also some people might charge you an extra fees for calling those functions. Yeah, you can turn this whole thing into a business model. And then let's access the person array. Yo, where's the person array? It's here. Okay, so we'll pass 0 as the index and call it. Yay, so now it did store 2 values, my favorite number and my name. Let's try another one, 5. And then your favorite number is 5. I decided. And then let's access the second element in the list of people. And that would be 5 for her favorite number. And this is her name. It's both stored. So yeah, I guess that's the end. I hope this was a light session. There are definitely other things that you should explore together, like upgradable contracts. Like we should also dive, or maybe like on your own time, you could dive into the modifiers and how they work, the different modifiers, and also the function visibility specifiers. This is an interesting exercise. Yeah. And also order of precedence for the operators. They exist, similar concept in other programming languages. So you can know which ones get executed first, which of these operators, similar thing they have here in Solidity. But I guess that is the end. Any questions? Are there free tools we can use without necessarily paying gas? Yeah, it's Remix. You can use Remix's like virtual environment for trying contracts. But if you want to, also every chain offers free gas tokens on their testnet. Every chain, just like Base, they have Base Sepolia. You can ask from their faucet. You can get some tokens for free, and then you can try it on their testnet environment. Every chain does that. So let's see, Base.
Yeah, but the issue
Awesome.
actually is for claiming faucets. In the faucet, we need a funded um, like account address, and so
Yeah.
people
Oh,
doesn't have that. So you need to fund it. Like
who doesn't have it? Base?
everyone, I guess. Um, yeah,
Oh.
you have to fund your wallet first.
Oh yeah, on mainnet.
Yeah, on mainnet, then
Yeah, true, true.
same for testnet. It's
Yeah, that's true. I forgot. Yeah, they made it harder now. I don't know why, but because of the bots, I guess. But yeah, you need to have like a very minimal, I think what, like $2 fee, I don't remember, but like 0.00 something ETH in mainnet in order to request from faucets. And that's just because like some people really abused faucets for so long. But yeah. Um, yeah, I think that's all so far. Any questions?
You are on time.
Yay! Good for me.
Nice. So some people, not some people, but a few people already go through the ciphering courses. Um, but yeah, just will share my screen. So I think it's this video. Mm, like, let me share. Tac. So just make sure, like everything we have covered today, it's here. So we can go here. Ta 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 tac 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 and tac until there. It's about this session. So please go through it. I think you need probably 1 hour. Yeah, it's like 1 hour itself. So you can deep dive by this way too. And then tomorrow we're gonna have another session. So with Raquel this time about error memory mapping storage factory. So you're gonna have to complete a few sections like this one, section 1 and section 2. So yeah, just feel free to go through it. So Khawla provides a great first overview of this section. Sorry for my English. And I know Mayema is also on the chat, so she's a Cypher ambassador. So also for technical question, don't hesitate to ask her, ask to Raquel, ask to Wala, ask to Emma. We have a couple of people well informed about everything related to that. Nice. Yes, on the Telegram group, we have a channel called Solidity. So for whatever your question, don't hesitate to reach out. Yeah, they are really up to reply to everything.
Yes, for sure. Feel free to ask any questions. We're
Yeah.
all here to help. Yes.
Thank you very much for the first session. Raquel, I don't know. Yes, Raquel, you are here, but I don't know if you want to to say something for tomorrow. Anything, don't hesitate. Otherwise, uh, see you just tomorrow. And don't forget to complete Siphon. And as I mentioned, after each session, you will receive an email, as we have done for the Discovery Basket, with our recap and what you have to do for next session. Okay,
Amazing.
okay,
Yes.
perfect. And thank you.
Thank you.
So see you
Bye
on
bye.
Monday. Yeah.
Take care.